Okay, we're going to be solving polynomial equations in factored form, so that's what we're going to do here. So factored form, when we're talking about factored form, what we're talking about is when a polynomial is written as the product of two or more linear factors. So for example, if I had this 2x squared plus 7x minus 15, here's my polynomial. When I factor this polynomial out, I'm going to have two factors, and it's going to be this, x plus 5 and 2x minus 3. And we're going to set this equal to 0 is what we're going to do when we're talking about factored form. Believe it or not, we are going to learn how to do this. Okay, so this is where you're actually going to be factoring polynomials soon, but this is how you do it. This is the answer to this one, but you're going to learn actually how to do this later on. So you could also possibly have 3 factors. If it was some other number, it might be something like this, 2x minus 3 and x plus 5 and x minus 7. You might have something like this, and again, it's going to equal 0. So this one has 3 factors. Okay. So one of the things we have to know is what we call the zero product property. Now, it has a bunch of different names, and so this is really important to know. Make sure you do understand that all these names are the same thing. They mean exactly the same thing. It's also finding the x-intercepts. That's one thing you're going to hear. It's the roots. You're going to hear that word a lot too, roots. And it's also solutions. And we're talking about solutions. We're talking about solutions of a quadratic. Okay, so all those words we need to make sure we understand. They are all zero product property, but that's just another way of saying it. And the way we do this, or the way we solve for this, is we are going to set each factor equal to 0. And then we're going to solve for x. One thing to keep in mind, you will have as many solutions as there are factors. So that's something to keep in mind. So on that first example on the first page, we had 2 factors and then 3, so we would have 2 solutions and then 3 solutions. All right, so let's do an example here. So example number 1. We might have 2 factors that look like this, k plus 1 and k plus 3. Again, we're going to set them both equal to 0 because we're saying it equals 0. So I'm literally going to do k plus 1 equals 0. And I'm also going to do k plus 3 equals 0. And then I'm just solving for k, just algebra. Minus 1, k equals -1. On this one, minus 3, that means that k is equal to -3. So my solution set for this, and remember, you have to have it in your squiggly braces. Okay, you have to have it like this. And it's -1, -3. That is my solution set for these factors right up here. That's my solution set for this. All right, let's do another one. Example number 2. So this time we're going to have 3d plus 6 and 2d plus 5. Again, we're going to set them equal to 0. So I'm going to take each one and set it equal to 0. 3d plus 6 equals 0, and 2d plus 5 equals 0. Solve each of these little baby equations, and we're going to minus 6 from both sides to get rid of that first. We're left with 3d equaling -6. When we divide both sides by +3, we get d is equal to -2. So that's our first one. Here, we're going to subtract 5 from both sides. We get 2d is equal to -5. We're going to divide both sides by 2. And we get d is equal to, since this does not go in even, remember we leave it as an improper fraction. In lowest terms, though, make sure you keep it in lowest terms. That is in lowest terms. And again, my solution set for this, with my squiggly braces, I get -2 and -5 over 2. This is my answer here. Okay, we have 2 more examples. First one here, we've got 2w plus half, and this time we're saying it is squared. Okay, so this is the same factor twice is what we're doing here. So we're, even though it's going to be 2w plus half times 2w plus half, we are really only doing it once because the same answer is going to be happening both times when we do this. So we're setting 2w plus half is equal to 0. We're going to minus a half from both sides. So I get 2w is equal to -half. Divide both sides by 2. And that means that we have w is equal to, and remember, we have, this is the math over here, -half divided by 2 means it's -half times 1 over 2, because it's 2 over 1 and we multiply by the reciprocal. So this is going to be -1 over 4. So my solution set for this one is just -1 over 4. And that's it for that. Okay, last example. This time we have 3 factors. 2x plus 1. We have 3x minus 2. And we have x minus 1. And all of this is equal to y, we're saying. And it is all the same. So when you say y, this is the same thing as saying equal to 0. Okay? All right, so we're going to go ahead and set each one of these equal to 0 or y, however you want to say it. So we have 2x plus 1 equals 0. We have 3x minus 2 equals 0. And we have x minus 1 equals 0. Solving each one of these baby equations, minus 1. 2x is equal to -1. Divide both sides by 2. So x is equal to -half. Add 2 to both sides on this one. We have 3x is equal to 2. Divide both sides by 3. And we get x is equal to positive 2 over 3. And the last one here, we're going to add 1 to both sides. So x is equal to 1, and that's done on that one. So again, in my squiggly braces, this is a set of numbers. This time I have 3 numbers. I have -half, I have 2/3, and I have 1. So that is how we solve polynomial equations in factored form, where you're finding a set of numbers that satisfy the equation. We have, in this case, like this last one here, we had 3 different numbers that would have worked.